This is a demonstration of Transfer Function for iOS by Studio 6 Digital, the dual-channel FFT that includes magnitude, phase, coherence, and delay finder. Transfer function is a two-channel measurement which works by mathematically subtracting the reference signal from the measurement signal. Because of this, we're able to do some great advanced measurements, including measuring the phase of a system, windowing out room reflections, and being able to adjust the EQ with program material rather than having to use pink noise. Here's our hardware setup for using transfer function with iPad. We've got iAudio interface 2 plugged into the iPad, the microphone plugged into the microphone input of iAudio interface 2, and the line input is the reference signal, which is the same signal that is being sent to the sound system. Most of the features of transfer function are available when you're using any other two-channel audio input, such as those that use the camera connection kit. Looking at the main transfer function screen, we have the magnitude and coherence plots on the top of the screen and the phase plot on the bottom. We'll have a look at the iPhone screen a little bit later. The two inputs are typically a microphone, which is the measurement channel, and a line input, which carries the same signal that is being fed to the sound system. Since the microphone signal is delayed by the amount of time that it takes the sound to travel from the speaker through air back to the microphone, we need to compute the delay very accurately. For that, we have Delay Finder. Transfer function includes a sample-accurate impulse response-based delay finder. To use it, just select an FFT sample size that will be large enough to accommodate the longest delay that you expect to find. And longer FFT sample sizes will work better when music is your test signal rather than pink noise. In this case, we're going to use music as our test signal. So we have computed the delay accurately. To apply it, just exit the screen. Now that we have the delay set correctly, let's watch transfer function in operation. And notice especially how stable the phase and magnitude plots are, even though we're using music as the test signal. Now we're going to look at testing using pink noise as the reference signal. First, connect the output of iAudio interface 2 to the input of the sound system. To use the internal signal generator as the reference signal for transfer function, we first have to go into Setup, Measure Source, and select Mic Gen Mode. This turns on the internal loopback feature in iAudio interface 2 so that you don't need a special Y cable. Now we just have to turn on the signal generator, set the level, and use the delay finder. Comparing this graph to the one produced using music, the main difference is that we now have plots that cover the whole spectrum. This is because pink noise is a full bandwidth signal and it contains all frequencies from 20 Hz to 20 kHz. The overall shape of the curve, however, is the same, showing how transfer function results are independent of the test signal. Let's have a look at some of the features available to us in transfer function. We're just running on room noise, but we can still see how this works. First, the smoothing picker. We can go from an unsmoothed display to 3rd octave, 1/6 octave smoothing, 12th octave, 24th octave, or 48th octave smoothing. And that applies to both the magnitude and phase plot. We also have averaging available, and we can go from averaging a set number of FFTs to turning that off completely, having fast or slow, or an infinite average mode, which just keeps summing FFTs over time and will eventually smooth out nicely. We also have our pop-up generator, and that includes all of our normal signals, including pink noise, which you may want to use. Other features of transfer function include the touch GUI, where we can zoom in on the frequency scale, pan the frequency scale, or pan or zoom the magnitude scale as well. At any time, you can double tap the display to get back to a normalized display. Pull the cursor across the screen to read out the exact frequency, degrees of phase, dB, or coherence percent. The value displayed here is the overall dB SPL from the measurement channel. We can tap it to make it larger on the screen or tap again to remove it. And this value is the maximum or peak frequency on the magnitude scale. Let's zoom in on this corner of the screen. You see we have our 2 dB level meters here for the measurement and reference channel. And if we touch up here, we get the actual dBFS level as a readout, which is essentially the headroom available in each of those signals. Let's have a look at the setup screen. From here, we can turn the coherence plot on or off. We can set a specific value for the coherence masking, or we can pick the FFT size. The FFT size can be set anywhere from 2048 points up to 32,000 or 32K. We can also turn peak tracking on or off, set the SPL readout to A, C, or unweighted, and pick an FFT data window, which is not the same as the FFT time window. We also have controls for audio pass-through, difference mode, and locking the graph scale. Now notice in this case that I've actually turned the coherence plot off, so let's see just how that behaves. Here's how the coherence plot and marker work when the coherence plot is actually turned off. When I go to adjust the coherence masking, the plot appears momentarily while I'm doing the adjustment so I can see what I'm doing. When I let go, the plot will disappear. Back in the setup screen, we have two buttons that control the input sources to transfer function, measure source and reference source. Tapping measure source brings up our microphone selection screen so we can pick which microphone we want to use. And then when we tap reference source, we get the reference source screen. Let's take a look at our options. With iAudio Interface 2, there are three possible input modes. First, mic and line. Use this mode when the reference signal is coming from an external sound system. For example, when you're using program materials such as music as the reference test signal for transfer function. Next, stereo mode. Use this when you want to supply your own unbalanced line level signals as an input, and then connect them to the line input 1/4 inch connector. And last, mic and gen mode. Use this when you want to route the internal generator back to the line input. You would use this when you're using the internal signal generator as the reference test signal. Next, we're going to look at how save and recall works in the transfer function module. So I've got a measurement up on the screen. I'm going to tap this icon to bring up the save recall screen. And then I'm going to name this as test 0. And then I'm going to store this file. And then I'm going to go ahead and recall a different file. There we go. So that's been recalled. So now let's look at how this works. I've got the recalled graph on the screen, and I'm also running in real time. Notice all the curves are different colors so you can tell them apart, and as I drag the cursor around, you can read off every value on the screen. And now if I go into Setup and select Difference Mode, we can see the difference between the stored graph and what's happening in real time on the screen. We've been running our demonstration on iPad, but let's see what transfer function looks like on the smaller screen devices such as iPhone and iPod Touch. First, you'll notice that all the graphs appear in one window. This can get kind of busy, so in the setup we give you the option to select only the magnitude, phase only, or magnitude and phase, as well as the option of turning the coherence plot on or off. All the other features of transfer function are available, including the cursor, the coherence masking marker, octave band smoothing, and averaging, as well as the generator. Here you can see that we can change the level of masking and make the graphs actually disappear, or change masking and bring them back on the screen. Double tap to normalize the display. We have the touch GUI to both zoom and pan the frequency and magnitude scale, and if we tap the delay field, we bring up the impulse response based delay finder. So that's transfer function running on iPhone. And that completes our demonstration of transfer function for iOS by Studio 6 Digital.
Get back homeward. wants to